Basically, it's an Inconel 625 or basically the nickel alloy. Yeah, it's a brake surface kind of tension technique. Basically, I'm on the leading edge, unlike stainless and carbon. I'm on the leading edge of the bottle. I open the keyhole. I dip into the. I see the puddle wash out first. So I open the keyhole and I see the puddle wash out, and I add a filler metal to the base of the puddle. There's a tug of war between the tip of the filler metal, the base of the middle of the puddle, and the big torch from the holding side. I can either hold the big torch in the middle and just wait till the brake surface between the puddle and the filler metal, or else I can move up 1/16 of an inch. My brake surface tension automatically in between the puddle and the tip electrode. Basically, it just washes out. It's like a manual processor, 6 to 10. That's why Inconel is actually very interesting. Well, like Inconel and Hastelloy, very interesting filler metals as well, because it's like the manual process of welding 6 to 10. So my filler metal, not filler metal, my fit up on here is 1/16. Land, about 1/16, 332 land, because I'm treating it like the manual process of 60-10. So I make one ripple at a time, basically. So I have about a 16th land, or about a 32nd of an inch land. It's a little bit of a land. You know, it's not a feather's edge, it has land. 532 gap. And, you know, I'm using 1/8 filler metal. Where is my flashlight? Try to zoom in here. So this is where I am so far. There'd be I already welded probably about an inch or 2 inches. I have the tie-in in the middle there. It's actually a very poor tie-in. But yeah. But this is how it is so far. See, it's just like 60-10. This is Inconel 625 I'm using, and this is just like 60-10. That's why it's so cool. Basically, I'm just getting into the middle of the puddle here. See, the thing with these nickel alloys is wherever you feed, where it will show up in a ripple. Basically, when I add the filler metal, when the surface tension breaks, I just see it just flow in and wash out that ripple. It takes just enough what it needs for the filler metal to just fill up the keyhole I made. That's really all it's doing. Basically, I'm just taking my sweet time on the root path here. You know, it's basically the The width of the root pass will be the same throughout the entire weld. There might be sections where it's wide in one spot and thinned out in another. It's going to be all the same width. Basically, we have the outside here. Let me figure if this thing will even zoom in or not. That's what the outside looks like. Let's peel this back. And those tacks are actually carbon steel. I just slapped them together on there. They're all slapped on there. Now this is Inconel 625 filler on carbon steel pipe. The reason why I have carbon steel pipe is because I have Hastelloy C276 pipe. 4-foot length, costs $3,800 for that piece. The problem is I do not have the proper and appropriate means to cut the pipe. What I have is a zip cut, or I have a bandsaw, and a lathe. Now the lathe is broken, so I can't use that. I have to buy a new lathe, but you know, a zip cut and a grinding disc. And what happens to these, especially the exotic metals, is you start cutting them. You expel a great amount of heat into the pipe. The heat interacts with the atmosphere and oxygen, and you trap oxides into the material. So this is an Inconel 625 root pass on carbon steel pipe. The welding machine is a Miller Dynasty 350, and if you notice, it looks just like a 6010. Looks like 6010 ripples. That's the reason why I like these nickel alloys. Is because they look so unique, look just like 6010 electrodes. Or sorry, a 6010 root pass. I just kind of like the look of this this metal. Just the way it deposits is really nice. We have 18 parts per million on the purge monitor. Now there's a number of things I'm doing incorrect. Well, especially the tape. You see this stickiness will just interact with the my weld zone here, and I'll have some issues, but since I'm just practicing I don't really care. But see, in a real situation I'd have the aluminum tape and I'd have this you know, tape to the back so it's not sticky or nothing, and non-sticky to the you know. But it's only practice right now, so it doesn't really matter. Yeah, it kind of reminds me of Pac-Man. Every time I feel it looks, or every time I add the filler metal and the surface tension breaks, it looks like Pac-Man, you know, chewing away at blocks or whatever. In case you're wondering why I'm not wearing any welding gloves, actually I am, I just have a lot of holes in them. The reason why I'm able to move so quick is because I have a little bit of a land on the pipe, and it solidifies my puddle once surface tension breaks. That's what I'm looking through right here. See, it's just a clear lens is all. There'll be the tie-in at the bottom. Ripple definition identical to 6010. And you see that pinhole right there where you snap out? That's where you break the arc. You have to feather your starts and stops with this Inconel, Hastelloy, these nickel alloys. You have to feather your starts and stops. You're going to have a lot of difficulty trying to burn out that pinhole. Much easier. It's also a fair amount of metal to burn out. Easy way to get discoloration with a lot of heat trying to melt that pinhole out. So you feather your starts and stops. Also, if you notice the speed I was going at, it is simply because, see if I can zoom out here, I have about a 1/16th to a 32nd of an inch of land. When I'm using the surface tension technique, I open a keyhole on the leading edge. See, I have a pinhole. I'm on the leading edge with the TIG torch, unlike stainless and carbon or chrome also, I'll be in the middle of the puddle. But I'm on the leading edge, I'll open a keyhole. I'll add the fill metal to the leading edge close to the base on the inside of the pipe. And then on the outside of the pipe will be my TIG torch. There will be a tug of war between the tip of the fill metal and the TIG torch, each on opposing sides. I could either move the TIG torch up 1/16th of an inch, or else I could just hold the TIG torch in place, and the surface tension will eventually break between the tip of the fill metal and the puddle. When it does, I see a metal wash in to fill that keyhole. Basically, the time it takes to break surface tension is also for the time it takes for the last ripple and all the heat to collect up and go straight to where the puddle is now. Now this last filament metal here is a Hastelloy C276, a little bit creamier than Inconel 625. Alright, now I just deleted a whole bunch of stuff on the camera because I only had 3 minutes and that's why the recording died. Anyways, there's the start. This is the left hand side. Anyways, this is the left hand side. It's very blurry, you're looking through a clear lens that's not very clear. We have the last probably 1 inch left. After the 1 inch is done, then I'll take this clear lens off and show what the root looks like. That's the last tie-in. Let me do something here. Let's turn the bottle, other way. Off that goes. There's the last 1 inch of the, the Hastelloy slash Inconel 625. I'm using 2 different filler metals. This would be the Hastelloy on the side, the Hastelloy C276. This would be the Inconel 625. Let me spin the camera here. Now this is the machine I'm using right here. I have it on DC. I have it on lift arc and I have the foot pedal on. The reason I'm using the foot pedal is because I rather have control over the overall welding current. I would much rather have the weld look aesthetic and uniform rather than having a spot where it's a little bit thinned out, being a little bit too hot, and maybe the root pass a little bit too wide or a little bit ununiform. I'd rather run with a foot pedal, and adjust accordingly if need be. No pulser, no sequencer. I think I have it on manual actually. Yeah, it's probably on manual. And ACA form for AC.
so that's not relevant. Set to 200 amps. The foot pedal, I don't know how many amps I was running. But yeah.